this open house will consist of a series of slides given by the program managers outlining the modeling programs, the modeling activities, and their place within the Office of Science, Biological Environmental Research, and ESSD, and then actually outline some of the opportunities available. At the end of this, there will be an opportunity for you to ask questions of the DOE staff. We will be using the raise hands feature. So when we finish and I call for questions, if you have a question, please raise your hand and you will be asked to unmute and called on to ask your question. Next slide, please. So this is one of the Office of Science's webinar, and the Office of Science has a commitment to professional behaviors and a safe, diverse, and inclusive environment. And this is not just lip service, this is taken very seriously. As part of being here, you are agreeing to this as part of the participation in this meeting. Action will be taken if anyone is seen to be violating this statement of commitment. So basically, when you read this, you know, we're all here working together. Please, if you have a question, make sure it's collaborative, and treat everybody else with respect. Next slide, please. So this is the overview of what's happening today. I kind of went through this already. So if we go to the next slide, and we'll go across to introductions now so you can meet the staff in this group. So I'm going to call on people one by one, ask them to unmute themselves and turn the video on if you have not turned, if you've turned it off, and introduce yourself. So Sujing, you want to lead us off?
Hi, good afternoon, everyone. My name is Sujing Davis. I'm program manager of the Earth System Model Development Program area within the EESM program. I mean, it's Renew and Bob. I think that's it for now. You'll hear more from me.
Hi, I'm Rainu Joseph, and we are part of the team of the Earth and Environmental System Modeling Program Managers, and you'll hear more about the areas that I manage soon. Perfect,
thank you. And Bob?
Yeah, hi, Bob Valerio, and I too am a program manager in Earth and Environmental System Modeling, and I focus on multi-sector dynamics.
Thank you. Jay?
Sure. Hi. Good morning. Jay Nilo, Program Manager. I run data management. I run the data archive, so I work very closely with the modeling group.
Awesome. Thank you. And Andrew?
Hey, Andrew Flatness, Scientific Program Specialist for the division. This role today, I set up the Zoom and helped Scott with some of the work there.
Which of course was very much appreciated. And finally, I'm Scott Collis. I'm 1/4 detail from Argonne National Laboratory. I'm working with Shima and the rest of the team to, as is the theme of this particular webinar, to increase access and communication about opportunities within ESSD. So without any further ado, I'm going to hand it over to Renew, who's going to lead us off today.
Thank you, Scott. And just as an FYI, Scott was one glue that brought all these activities to bear as we worked on the different presentations. And this town hall, I hope, is useful to everyone. So as part of this a slide deck and the presentation, there are going to be a lot of slides. This is just meant as information. You'll have a lot of detail, but we won't be able to cover all the detail in the short time period. So please feel free to use the deck as appropriate. So to start off with, we are part of the Office of Science at DOE, and the Office of Science is the largest funder of basic science in the country. And there are 6 offices, and we belong to the Office of Biological and Environmental Research. And Dorothy Koch is going to be the new Associate Director starting next Monday, 1 week from today. We, as part of the Earth and Environmental System Sciences Division, our division is led by Gary Gianat, and we as part of the modeling program, interact closely with the Office of Advanced Scientific Computing Research through a SciDAC program that you'll hear from Zhuxing Davis. So why is the Earth and Environmental System Sciences Division within DOE? Earth system variability, climate change, extreme events all affect the energy and infrastructure security. And because of that, it is important to understand that. And so our division focuses on intense field observations, process research, process modeling, and global, regional, and multi-sector dynamics modeling to understand the energy and infrastructure needs. So as part of our division, we do have three themes or three foci. The activity on the left represents the atmospheric systems research. Shaima Naziri is, I can see her on the call, and she is one of the program managers in this program. On the right, you have the theme that, or the programs that focus on environmental system science, both from the terrestrial ecosystem point of view, as well as from the watershed point of view. And there is process research, intense observations all happening in these programs, and they also do process modeling. And the block in the center indicates the Earth and Environmental Systems Modeling, which is the integrator of all the activities that are happening in the division. So you do have an Earth system model development component, a regional and global model analysis component, as well as the component that focuses on the interaction between the natural and the human system. Data management is the program that focuses on data across the division. And we've had a strategic plan in the past, and you'll find all those community resources in the links that are indicated here. So we've introduced ourselves, and just as a quick to provide a bird's eye view of Earth and Environmental Systems Modeling, our overarching goal is to develop and demonstrate advanced modeling and simulation capabilities to enhance the predictability of the Earth system. And our total funding is about 115 million, which is distributed between Earth system model development activities, primarily focusing on the development of the Energy Exascale Earth System Model, or EESM. So this is a first way of trying to remember acronyms. So ESMD focuses on EESM. You have the regional and global model analysis, or the RGMA area, that focuses on the analysis of the whole system with models and observations, and multi-sector dynamics looks at the interaction between both. The themes below indicate the different unique capabilities that we bring to the table, and you'll hear more about them as we go through the presentations. Though we are three different program areas, we work closely together, and I'm not going to go in and explain the interactions between all of them, but this gives you an idea of the way we work together as a team, both from our end as well as from the point of view of the scientific community that's funded as part of our portfolio. And we have a lot of jointly funded efforts also that increase the synergies within the team. This slide kind of indicates the types of investments that we have from the modeling part of the portfolio. We do fund both lab and university scientists. From the lab investment point of view, we do have science focus areas. You'll hear more about it. These are large lab projects that can be viewed as a hub for that particular topic. And there are over 10, nearly 10 of them, at least, as part of the modeling portfolio. These are places where the university community can come and interact with scientists and make connections. So, so for instance, if you look at the university investments, you do see the last bullet there that says collaborative to lab projects. And this is one way that the collaborations happen. University investments are primarily through funding opportunity announcements, and you'll hear more about that later on too. We also do have cooperative agreements that are led by universities, and those are also places where the university community can interact with the activities in our portfolio. So this is just to give you a quick overview of all the large projects that are part of our portfolio, actually all the projects that are part of the portfolio. For instance, you do have the lines, the blue highlights across at the bottom that indicates our university component of the portfolio. The others are large SFAs or cooperative agreements and larger university, larger lab projects that you see on top. And we'll give you a quick idea. We're using this presentation to give you a quick idea of what these projects are about so that you can potentially connect when you get an opportunity and a chance. I did mention interactions across the whole system, and the 3 purple lines at the bottom are activities that are focus on coastal active dynamics, and so we'll be talking about them also. So now I'd quickly like to turn this over to Zuxing Davis, who'll talk about the model development activities.
Okay, thank you, Renio. So for next 10 minutes also, I would like to provide you a brief overview of the Earth System Model Development Program Area activities of you would call ESMD. Next, please. As Renio mentioned earlier, central to ESMD is the Energy as a Skill Earth System Model, or EESM. Simply speaking, EESM is a DOE model on DOE machine for DOE mission. And the goal of the ESMD is to support the EESM development to address the grand challenge of ancient predictions of the Earth system variability and change, with emphasis on the most important scientific questions relevant to DOE mission. The development strategies are to drive model development with scientific questions centering around the water cycle, biogeochemistry, and craftfield processes. All 3 have been identified as grand challenges in our division strategic plan. And also we aim to develop an integrated Earth system model, including all Earth system components and a human component across different temporal and spatial scales. We do this by pushing high resolution frontier, by bridging gaps in scales and processes, and by quantifying uncertainties through large ensemble simulations. At DOE, EESM also leverages the department's world-leading HPC capability for computational advances and scientific leadership. In addition, EESM also integrates innovative emerging mathematical computational methods, tools, algorithms, and technologies into model development. Next, please. Within the ESMD portfolio, EESM project has more than 60% of the total budget and is a central driver for EESM development. The project is tasked by DOE to deliver a major version of the model within every 3 to 4 years. Therefore, the project is on a rigorous model development cycle. The project has very focused scientific questions, well-defined timeframes, well-designed goals and strategies for short-term and long-term. Other ESMD projects contribute to EESM development in different ways on different timeframes. The SciDec project, Renio also mentioned a little bit earlier, from the second largest portion of the ESMD portfolio are to support deep, necessary collaboration and integration between earth science scientists from BR side and also mathematical computational scientists from the Advanced Scientific Computing Research Program Office, or OSCAR Program Office. ESMD also supports other projects like the COSO projects to address ongoing DOE priorities by enhancing EESM capabilities in relevant areas, also to address particular climate modeling challenge for models representation of cloud, aerosol, and their interactions through the EAGLES project. ESMD also supports the career development of distinguished early career researchers from national lab, from DOE, and also universities through Office Science-wide early career research program, and also to entrain fresh talent from the academic science community through open university funding opportunity announcements, we usually call FOAs. With a relatively small budget, ESMD also supports very important interagency activities to collaborate with other modeling center activities within US and even internationally. In addition to the ESMD portfolio, EESM is also part of larger DOE ecosystem, particularly within the Earth Environmental System Sciences Division, we call EESD. Through this, EESM provides modeling capability for others to address DOE relevant science questions. Meanwhile, EESM also integrates the knowledge, data, and tools gained from other research projects to inform EESM development. For the EESM program, for example, all the RGMA projects require the inclusion of EESM as an essential component. For MSD, managed by Bob Valerio, one good example is a GCAM global change analysis model that has been coupled into EESM to represent a human Earth coupling component. And also there are very important connections with other programs as ARM ESR for data or connecting different skills and ESS, also with the OSCAR program offices. Next, please. So EESM project has more than 100 scientists from 8 DOE national labs and multiple universities. So in a sense, it's a cross-laboratory initiative in Earth system modeling. Next, please. And the leadership team also reflects this nature. So in a sense, the project brings together the unique capabilities from all 8 DOE national labs and universities, covering a wide range of expertise in different areas of the earth science and also computational and mathematical disciplines to tackle this grand challenge in Earth system model development. Next, please. Here is a snapshot of EESM major timelines and achievements. The project started in 2014. EESM version 1 was released in 2018. After that, EESM became an open development project. EESM version 2 was released in 2021. Compared to version 1, version 2 is a better and faster model with regional refined modeling capability, or RRM, in all its components. Currently, EESM version 3 is under testing and is on track to be released by the end of this year. We are expecting exciting improvements, especially in the atmosphere component with much improved physics. EESM version 4 planned released in 2026, envisioned to be a GPU-enabled, fully coupled EESM, providing foundation for digital twins of the Earth system regionally and globally. Due to the effort of the project team during almost a decade from now, and with strong support from DOE, EESM has made many exciting advancements. Currently, EESM has a few unique leading capabilities, including its ISA-skill readiness, through the development of the first benchmark of its kind by running 3-kilometer global simulations of the simple cloud resolving EESM atmosphere model, or SCREAM, on the DOE's ISA-skill computer Frontier, which is the first and the fastest ISA-skill computer in the world, with record-setting performance of more than 1 simulator year per day. This exciting result has earned EESM spot as one of the 3 finalists for this year's Golden Bell Prize climate modeling category. In addition, EESM also unique in its RRM capability in the sense that it is the first Earth model running fully coupled global simulations with RRM in all its components, except River that has completed climate production simulations. And EESM is also unique in representing coupled human Earth feedback with this component in that. On the bottom right here, I list the different model configurations of different versions of EESM with different resolutions. I will not go into detail, but leave here for your reference because our slide will share with you later. Next, please. So here is a list of the SciDec projects we are currently supporting. There are 7 projects totally. As you can see, they're covering almost each component of the EESM, from atmosphere to ocean, sea ice, land ice, and river, and also the coupling between atmosphere component, other components. And for each of the 7 projects, we have the participation from different universities. And this is a partnership between BR and Oscar, as I mentioned a little earlier. The all 5-year projects with a budget of total 70 million. Next video. So here is the Eagles project mentioned a little bit earlier. Again, I will not go into detail. I just want to say that this project is to address a grand challenge, not only unique to EESM, but also a challenge for a lot of other Earth system modeling centers. Next, please. So here is a list of resources for you, which you can find more information about ESMD, about EESM, and how to keep updated with the EESM progress information, and other major large body projects, including SciDec and Eagles Research Awards. For the modeling for the coastal projects, ICOM, Compass, and Interface, I think Renew Bob will mention them more later since we co-founded these projects. With that, I think I will hand back over to Renew. Thank you.
Thank you, Su-Jing. You'll get a chance to ask questions at the end. So now focusing on the regional and global model analysis part of the portfolio, for which I'm responsible. The overarching goal here is to quantify and enhance a predictive, process level, and decision relevant understanding of variability and change. And you do this by advancing capabilities to design, simulate, evaluate, and diagnose and analyze global and regional Earth system models. And you don't do this in isolation. You always use observations to evaluate and inform your models. So this particular program focuses on using any modeling tool, but we'd always emphasize the use of EESM as part of the portfolio. When you look at this symbolic representation of RGMA, you do see that there are 6 pillars, which are the 6 science themes. And this is something that almost everyone can relate to, which is, those are different ways of looking at the Earth system so that you can analyze and understand the Earth system as a whole. Earlier in my presentation, I mentioned there were large projects or SFAs. There are SFAs that link to each one of these topics, or maybe there might be 2 activities that map into one topic, like extremes. And I'll quickly go through those examples. But I also want to indicate here that the SFAs form roughly 50% of the portfolio, but nearly 30% of the portfolio is led by universities. And that is in response to the university funding opportunity announcements that come out. Also, we do have cooperative agreements with large centers that I'll indicate as examples. So let's just focus on the right in light blue. Here, as I mentioned earlier, we do emphasize the use of EESM, but we also encourage the use of a hierarchy of models ranging from emulators to the more complex Earth system models. We encourage the use of all the CMIP models, the model intercomparison project models, development of multi-model hierarchies, and all this to understand the particular, to understand and address a particular science question. In terms of capabilities that we also support, it includes developing diagnostics that the community can use to evaluate models, developing metrics to evaluate models, and you'll find links to all those activities in my slide deck. We look at the lab activities as hubs for the science. As there are funding opportunity announcements come through, it would be useful to look and link with the appropriate SFAs and the large projects, so that there will be more interaction between the university community and the labs. So now I'm just going into a list of different SFAs and large projects so that it gives you a quick idea. The first topic focuses on water cycle. It was one of the pillars. And this activity called Water Cycle and Climate Extremes Modeling is out of PNNL, led by Ruby Lung. And it looks at large scale as well as fine scale processes relevant to the water cycle. And one of the unique aspects is that this activity was one of the first activities that focused on looking at mesoscale convective systems in the global modeling sense, not from the weather prediction point of view, but from the Earth's climate modeling perspective, to understand the statistics. And I did mention the use of a hierarchy of models. This gives you a good example of the hierarchy. They go all the way from parcel models of MCSs to all the way to SCREAM, which is the atmospheric component of the energy exascale Earth system model. And they bring in the good tools from machine learning and so on. Now, another activity that focuses on extremes, and this is more from the point of view of extreme events. They focus on the characterization, detection, and attribution of extreme events. This is led out of Berkeley, and the PI is Bill Collins. And the unique aspect that this team brings to the table is the fact that they've developed routines to track tropical cyclones, this actually, their collaboration in 2018 with the NERSC team at Berkeley enabled them to be part of a Gordon Bell Prize on tracking and identifying extremes. So they are a very computationally savvy group that looks at statistics. Now, moving from the water cycle and extremes to look at the biogeochemical cycles, Rubisco SFA focuses on bringing together observational capabilities at DOE and with from other agencies. And they also bring in the modeling capabilities, and model evaluation has been a very strong point of it. Folks who are involved in the biogeochemistry analysis part of things must be familiar with ILAMP, the International Land Model Benchmarking Tool that actually has rallied and brought together the community so that you can evaluate the biogeochemical processes, not only as metrics, but also as process with respect to process interactions. And this is just to indicate that from the university point of view, good collaboration, you can either contribute to ILAMP or use ILAMP in your activities. So this is one of the capabilities that we provide. Moving over to the next topic, HILAT, as the name indicates, it focuses on high latitudes. And for this particular round, they are particularly focused on Arctic and Arctic amplification. They look at processes within the Arctic system and between the Arctic and the low latitudes. And they bring together EESM as well as CMIP models to understand Arctic amplification. One of the strong capabilities that this team provided is that they worked together with the EESM team to create the first regionally refined mesh completely in all coupled components except for ice sheets. So sea ice, ocean, and atmospheric components have variable resolution over the Arctic, and the simulations are out there right now. And this community has now taken it a step further, and they are in the process of organizing a consortium for advancing Arctic science. And actually, this is open to the public. If you're interested in high latitude efforts, please do go and register for the workshop and be part of the community. They do have an early career school also associated with this activity. It's going to kickstart in February of next year. So this particular project, PCMDI, anyone who has used model intercomparison project output will recognize PCMDI. It existed for over 20 years, bringing together the different models, Earth system models, and for the point of view of model evaluation. And now they collaborate closely with the Earth System Grid Federation too. So right now, the main focus of PCMDI is on understanding the science from the cloud feedbacks perspective, as well as developing diagnostics and metrics to evaluate this whole suite of 30 plus output from 30 plus modeling centers across the globe. They are also focusing on decision relevant regional climate projections and understanding, developing metrics to evaluate them. This particular project is a cooperative agreement run out of NCAR, and Jerry Meal is the PI. And you can go to the website to get more information. They work on different aspects of predictability, and this the unique thing contribution for DOE is the fact that they do detailed analysis with both the CESM model as well as the EESM model to help enhance the capabilities of both modeling centers. This is a quick slide to indicate all the projects that you could potentially connect with, and this is just for information. And I'm handing it over to my colleague, Bob.
Thank you, Renu. So I'm Bob Valerio. I'm going to talk about multi-sector dynamics. Next, please. So the real focus of multi-sector dynamics is to look at the complex interactions and coevolutionary pathways within the integrated human Earth system, including natural, engineered, and socioeconomic systems and sectors. And in the illustration, you see some of the interacting systems and sectors, and then the influences, both human influences as reflected on the left in blue over here, and then the natural influences on the right, and they could be stressors or influences or some combination, and how it affects the fully interacting set of systems and sectors in the center. Next page, please. So as part of this work, we're really interested in looking at forces and patterns that give rise to trans-regional, regional, and sub-regional landscape evolution. Stabilities and instabilities inherent in those systems subject to those various forces and interactions, and then looking fairly distantly into the future, oftentimes as long as a century out, looking at the future forces and stressors and disturbances that can influence and reshape these systems with some examples on the right. And we're interested in gradual as well as abrupt transitions, maybe even more so in the abrupt transitions and tipping points that lead to fundamentally different states in a very rapid time frame. Next slide, please. This is extracted from a recent Vision 2030 Vision report at the Community Practice that we fund, which is something that you all may want to engage in. It's open to anybody and everybody, both funded researchers and domestic and international researchers that maybe don't receive funding, as well as other agencies. And it's broken into a series of working groups I'll talk about in a bit, but this gives you some idea of the methods and foci and some of the analytic challenges confronting the community. And this is their version of how they see themselves and how we see them. Next slide. You saw a more comprehensive set of illustrative domains when Renew first presented and showed some of the areas where we have somewhat unique focal points and capabilities. This is an extracted version that I have spent and we have spent in the MSD community an inordinate amount of time working. And the methods and tools that we develop, they're basically oriented around a lot of open source capabilities, community capabilities. This particular field works a lot with emulators of detailed models and simulations. And the interest is really to explore a lot of the uncertainty and the dynamicism. And as such, you quickly run into computational overload if we're trying to carry every system in inordinate detail, like you would for the select systems in the Energy Exascale Earth System model, which is our flagship model at high computational intensity and high resolution and high levels of complexity. So for us, we're really interested in understanding a lot of the uncertainty and the collective behaviors that result from that. We often use artificial intelligence and machine learning methods fused with models in hybrid fashion. This community is very engaged in scenario development. For those familiar with the IPCC, a lot of our researchers are front and center on the shared socioeconomic pathways and the representative concentration pathways. But more specifically, we're looking at more focused efforts within the US now. And that does involve also looking at stress testing the systems, developing complex storylines, telescoping modeling capabilities, and again, looking at these nonlinear behaviors, oftentimes with information provided by my colleagues, Renew and Zhu on extremes and the changing nature of extremes. Next slide, please. This is a cross-section. I'm not going to go into all of these. I think Renew did a nice job of summarizing quite a few of them in that integrated slide in the beginning. But I do want to mention that within MSD, there's a strong focus on co-funded and funded teams, but particularly on partnerships across teams. Even within the MSD space, you heard Renew and Zhu talk about how we work together across program areas. But within the projects that I fund, and it's part of the reason we fund the Community of Practice, right, is building this network of highly interactive teams and teams of teams that build more faster and deliver more by working symbiotically and synergistically with each other. And next slide, please. So this is an example project, the integrated multi-sector, multi-scale modeling activity. You can see, it's really intent is to develop flexible open source capabilities. They have more of a regional to local focus. Their current project, and this is again a national lab scientific focus area, or SFA, is focused on looking at the energy, urban, land, water interactions and systems, and then with influences that include snowpack, heat waves, drought, markets and trade, population dynamics, and technology change. And they study the evolution and the tipping points, and there's a very, very strong capability in Western water and the energy system and agriculture. Next slide. Here's an example of one that works more from the regional scale to the global scale. And you may be familiar with this. It's the GCAM model is funded, the Global Change Analysis Model. is funded through this global change intersectoral modeling system activity. And it gives you an idea of the kinds of influences, responses to influences, and feedback on influences you can see in these various columns where they've color-coded the existing capabilities, the newly proposed capabilities, and the desired or intended future capabilities they will be exploring within several years. And there's a large cross-section of components and influences and responses to influences and feedbacks listed. On the right, I would endeavor to say, and I think Zhu already mentioned this, that this GCAM model that really synthesizes and brings a lot of this together. It's a computable general equilibrium model, has significant economic components as well as physical and natural systems components. And it's a link, it's built into significant portions of it, but not all of it, are built into the EESM. Okay, and then Renew and I oftentimes engage in collaborative research, for example, through hyperfacets, to bring some of these capabilities to bear as well in these more kind of synergistic modeling efforts. Next slide. This is an example of a large cooperative agreement, and I just want to check my time. Okay, cooperative agreement led by the Penn State University with, you can see in the upper right, significant subaward funding and collaboration with other institutions. And their current rendition of this project as a cooperative agreement is the upper, you can see in the upper right, where the boxology on the left gives you some idea of the interacting systems and the way that they model and think about conceptually how they approach this. But you can see the broad range of geographies of interest, the topics of interest on the right. Next slide. This is another project, a little bit of a smaller cooperative agreement with the Massachusetts Institute of Technology. They're doing some really interesting work in the Mississippi River and Gulf Coast region, and they have a risk triage approach that they've been using. And this group in particular, you know, going from human systems, natural systems, pattern scaling, probabilistic ensembles. What I'm really impressed with this group, they've developed a new machine learning-based scenario discovery process, which we're applying, and we've briefed to the U.S. Global Change Research Program as well. But they're applying this to use the GCAM model as one example to develop and study the kinds of factors that matter in different regions, the scenario elements themselves, that when they bring these in combination, which subsets of combinations seem to be most germane to particular regions, so we can narrow down our study space. So it's a very cool technique, and it's delivering some very interesting results. Next slide. Some examples of the role of MSD in interagency and interagency leadership efforts. I'm not going to go into all of these, but you see a nice cross section. You can come back later at your leisure. Next slide. One of the key capabilities or components within this system, the MSD system, is MSD Live, which hosts both community data and computational software for use by the community, and that can include you. You should check it out. You will have total access to this as well. Next slide. And this is links to join the multi-sector dynamics community practice with the working groups and hot links identified on the right. Next slide. And here too is my list of relevant, it's a roadmap, if you will, to the program, the projects, and resources that you can access and gain a tremendous amount of information and knowledge about the program. So I'll stop there, I think, if you switch on, and I'm going to be turning this back to Renew to talk about federated projects.
Thanks, Bob. So when it comes to federated projects, these are projects across the 3 program areas, or maybe across 2 program areas. And so any one of us could have given this part of the presentation, but I am here. So hyperfacets, Bob mentioned this. One unique aspect, of this particular project is that they engage with stakeholders on a regular basis and get information and feedback from them to understand what are the basic science questions, and then they go into more process understanding, and then provide guidance of their understanding back to the stakeholders. So this is a very dynamic process, and the MSD and RGMA jointly fund this activity, though we use E3SM extensively in this particular part of the portfolio. So in some sense, ESMD is an unfunded collaborator in this particular activity. And how do they do this? They do it through different storylines. This is one of the projects that has brought the storyline concept back, revived the storyline concept in terms of understanding different extreme events or different features that happen. So these are examples of the different storylines, and I think both as part of Bob's list of links and mine, you will find ways in which you can engage with the Hyperfacets project. They do have monthly webinars that you can call into to get a feel for what's going on. And I'm not going, all these topics are very exciting and interesting, and unfortunately there isn't time to talk about them. Now I'm going to quickly indicate the 3 federated coastal projects across the 3 parts of the portfolio: model development, model analysis, and multi-sector dynamics. The first one I indicate here, the PI is Ian Krutunis from PNNL, and it focuses on the mid-Atlantic. It looks, because all the 3 program areas are focused on this, you do have very strong model development components that look at developing characteristics for coastal flooding and ocean land interactions. As part of ESMD, you have the focus on understanding the large-scale drivers along that particular region, and also looking at the interaction between the natural and the human system. The 2 regions that are where primarily the focus in the previous, I mean, it's going through a transition right now, during the previous phase, they focused on the Delaware and the Susquehanna River basins. You can go to the links to understand more about it. The second coastal project that's federated focuses on a different type of coast, which is the Arctic. So this, the interface project focuses on the North Slope of Alaska. And so you're looking at things from a different point of view. You're looking at things from the sea ice, ocean dynamics, interactions, looking at coastal change because of that. It's different from the point of view of permafrost hydrology that is important in this particular region, and so on. And multi-sector dynamics has a different focus, which is on the shipping, the settlements, and resource development as part of the interface project. The third coastal project focuses on the Great Lakes region. This is, again, a different type of a coast, which is a coast along the Great Lakes region. And so it has a whole hierarchy of modeling capabilities, going all the way from capabilities that inform and use the E3SM to regional models, to watershed models, and also the human systems interaction aspect brings in the agricultural focus in the Midwest. So, and this project is also led by PNNL, and Rob Hetland is the PI. So now transitioning from that to my colleague's program. Jay, do you want to talk about it?
Sure, Renu, no problem. Now for something completely different. This is just a discussion, real quick discussion of data archives in support broadly of the modeling effort. The biggest one is Earth System Grid Federation. This serves all the IPCC and CMIP data. This is a large international effort. There are international hubs. There's 72 hubs as of a few weeks ago up online. It's just a way of disseminating and gathering the data broadly for international research, that even goes all the way down to multi-sector dynamics that Bob and Renew with CMIP and PCMDI we're talking about. This is the archive that supports that. It is open source, open science. That's the kind of the thrust of it. And it's owned by DOE on behalf of the community. So Renew, yes. Next slide is we're presently redesigning the interface. It was originally designed for scientists, and we all know I'm as guilty as the next person. It made sense to me, but now we're redoing it, making it easier, friendly. So we're using a metagrid approach. And of course, you can always go to it and submit questions, concerns you have, and help drive this effort. It's very much, this is being built for you. So please, any and all comments are welcome. Keeping it short and sweet, that's it. You're welcome. Okay, thank you, Rudy.
So as part of connections with ESGF, the metrics activities that are being developed and the model output that we have will into the future be linked, or we see the potential of it being linked through ESGF. Now over to Zuxing.
Okay, thank you, Renew and Jay. So I hope by now you're really excited by our program's part research activities and really want to engage with us. So how to do that? Each of us have provided some resource links like by the end of our overview. But here we provide some additional information and also organize all three of our information in a way that convenient for you. Next, Renew. So for the funding opportunity announcements or FOAs, within the modeling program, we issue an FOA every other year. And typically, the projects from this FOA are 3-year university-led awards. And the topic and release dates vary from year to year, but we typically release them in the late fall or early winter. For every 3 years, we participate in the Office Science-wide Early Career Research Program. I think I already mentioned a little bit earlier with the associated FOAs. This FOA is open to both the academic science community and also DOE national labs. And every 5 years, there will be SciDec, the scientific discovery through advanced computing research partnership FOAs supported by both BER and Oscar. And the project from this are 5-year awards. Again, they can be led by either university or by DOE labs. EESM also participates in annual funding opportunities through Office of Science Graduate Student Research Awards. It's a great opportunity for your students to engage with DOE large effort. Next, Renew. So here we are including a lot of opportunities, including early career research program across Office of Science, Small Business Innovation Research, or you recall SBIR, and also AppScore you may be familiar with. And also the Renew, FAIR, and CRC are relatively new initiatives that you must be very familiar with, I assume. If not, you definitely want to check them out. Next. You can also find more opportunities through the Office of Science website, BER funding opportunity page, and also through each program within our division. For example, we put our the EESM modeling program webpage here. You can subscribe to Gov Delivery, grants.gov for funding opportunities. And also you may be interested in checking out the scientific user facility webpage and workforce development for teachers and students. Next, Renew. You can find a lot more information about the modeling program from our website, including all three our components. And again, we include here major websites like EESM website, multi-sector dynamics website. And each of our program area, we have our newsletters you can subscribe to, and we have regular updates through them. We also have YouTube channels. You can subscribe to those, and also MSc community or practice blog. They're very interesting. Yeah, you definitely should visit them. Next, Renew. So here you are more than welcome to join our webinars, EESM webinars and RTMA monthly webinars. MSc also have different working groups, Bob mentioned a little bit earlier, with different topics and emphasis listed there. Next video. And there are other ways to engage with us, like all the program managers within the division, and also including the modeling program. We regularly attend important meetings such as AGU, AMS. We usually convene more than one town house. So please join us, check the AGUM website. We'll be very glad to see you there. And the BR usually have a booth in the SVD hall. I think we have rotation program managers throughout the meeting time, and we will be very happy to see you there and talk with you. We also have the BR advisory committee, and we call BRAC, regular meetings, usually one in spring, one in fall. They are completely open to public. You can register online and join them remotely. And we always need reviewers, not only the FOAs, but also we have a lot of larger projects as we try new reviews. So we always look for reviewers. We will really appreciate if you can volunteer yourself to be reviewer for us. Send us your CV and tell us your area expertise. We will definitely keep you in mind. And through that experience, you can also know more about our portfolio. DOE is also part of the US Clever Interagency Group. Renew and I represent our division in the group. So we co-found the research activities with other agencies, mainly NSF, NOAA, NASA, and ONR for activities that within the DOE's interest and scope. For example, the climate process team projects, and also different work group, workshop requests. And you should also look for opportunities to serve on different US Clever panels. It's a great way to engage with program managers, not only with DOE, but also other agencies. And we also participated in the IRPIC collaboration, IRPIC, through different mechanisms. You mentioned earlier that there are some IRPIC modeling community practice, and also Renew is co-chair for the IRPIC Priority 2 on RT system interactions. Is that last slide, Renew? Yeah, so I think that's it. We're open for questions. I'm sure you have lots of them because we went through everything pretty quickly for a lot of information there. I will hand back to Scott.
Wonderful. Thank you, Zhu. Thank you, Renew, and thank you very much, Bob. So we're at the question and answer part of the open house. So I'm going to invite anybody who has any kind of question. Now is your time to raise your hand or unmute yourself. Otherwise, I will ruthlessly pick on people who've also turned on their videos who may have a question as well. So are there any questions from this group? I do see Hernan has turned on his video. Do you have a question there, Hernan?
Yeah, thank you. Thank you very much to all of you for the nice introduction, and the presentations was very comprehensive. I'm actually working with the Robisco group. We have some meetings going on and talking with them. And I also work with some people in Berkeley lab through some machine learning activities, and co-leading an AGU session called Machine Learning in Hydrology in this coming AGU. So I'm trying to little by little get involved into the DOA system. But I wanted to ask how critical it is for us as university professors to have partnership with some scientists in laboratories, or some colleagues in DOE, because sometimes part of the funding might probably be used to support researchers at the labs, and then part of funding be used to support our students here at the universities. So please tell us about how critical it is, and if it is critical or important, how can we engage people at the labs?
Mm-hmm. So I can take a shot at it, and then my colleagues can join, just because you mentioned Robisco, right? So if there's a funding opportunity announcement and there is an ability to link with labs, you can, and it's not a must. We don't say that you have to, but if you think that the lab will, interacting with the lab scientists, with them getting 10% of the funding or so, if you think that that will enhance the capability of your project, then it is good to engage. But if you're just doing it just to have it on paper, I don't think it's really worth it. So it should be something mutually beneficial, or at least beneficial for you as the PI as you apply for it. And normally, sometimes when there are applicants and you say that, hey, we encourage collaboration, and people just randomly stick two CVs together, the reviewers automatically pick on it, right? So you want to do it as appropriate. If there is a need, you can collaborate. And also collaborating without funding, if you want to do it without the FOA, you're more than welcome to do it. And if you think you can bring unique capabilities to the project, reach out to the lead PIs. That's why I put their names there. Reach out to the lead PIs and see how you can provide some unique contribution to the effort. Mm-hmm.
Perfect. And I think Bob has a response as well.
Yeah, I was just going to, echo what Renu said. In some cases it makes sense, in some cases it doesn't. There's a role and a place for one-off research that pushes the entire field forward, right? And then there's oftentimes, but not always, a desire on our part to see how work of individuals can contribute to our leadership class modeling efforts, right? That oftentimes are much larger teams, and it's not limited to national labs. It could be large cooperative agreements, it could be other grants, et cetera. But we're looking for synergies where the sum of the part, the whole is more than the sum of the parts. So where you can already anticipate and build those kind of perspectives and leverage. We like to see leverage. We like to see opportunities where you're influencing the development of other areas, right? And if you've already given thought to that, as opposed to rely on publications, that's just a step forward in the right direction. So.
Excellent.
Yeah.
Thank you very much.
Mm-hmm. Yeah, I think, Bob, I think I do not need to re-emphasize. You're more than welcome to join us, please. And we always welcome the university researchers' contribution, either to through regular FOAs or talk with project team members, and also for EESM. If you go to the website, you will think you have some kind of expertise, really can make EESM better. There, you can submit simple collaboration requests. Yeah.
Perfect.
Thank
Do we have other questions?
Hey, Scott, just in case some people are less familiar with Zoom than Teams, we might mention that the raise your hand option could be found in the reactions.
Yes,
icon
sorry.
at the bottom. Yeah, if you click on that, it's not just smiley faces, but that's where you'll find raise your hand.
Very good point, Bob. I have what they call the curse of knowledge. I assume everyone knows what I know. Juan, did you have a question there?
Sure, I'll venture to ask a question. So Juan Restrepo from Oak Ridge, and I'm in the mathematics and computation group. But I do a lot of climate and meteorology. So we've developed some techniques, probabilistic techniques for dynamics and for assessments. And we're wondering what's the situation with SciDAC and how can we contribute to this effort? And when is the next recompete, or what can we do to join it?
Yeah, so thank you for that question. So yeah, I'm excited to hear your kind of has expertise in the kind of computational mathematical side, because really very unique aspect of the EESM actually computational capability come from the SciDAC partnership. So for that partnership, we have like every 5 years we have opportunity. Last time was in 2022. So I guess next one will the call actually will come out 2026, and the review panel be 2027. But I think the relative cycle is long, but you should talk with like our SciDAC PIs or team members, at least I put a list of those projects on that slide. You should, if you're not familiar with, you should talk with Oscar they have SciDec team members, include both members from DOE lab system and also a lot of universities. Just engage with them. A lot of opportunities for collaboration. Just start with simple conversation, right? Just talk with talk with people. Then
And I just want to add on to that. One of the really good ways to get notified of all these funding opportunity announcements is to make sure you sign up for delivery.gov. So again, that information is there on the slides. Crystal, I see you've got your hand up.
Hi, yes, thank you very much. Good morning. I was just wondering, what are the links with BEER or the BER program? And then, because I do a more metabolic modeling, so I don't know if any of your efforts that are going on would benefit from this, and then if this is how you are connected with BER or some help on that area would be very good. Thank you.
Is this the biological and system sciences division, our sister division within BER that does the biological research? Is that, it's probably.
I think so, yeah. So the lab that
EESM.
now we always work with them mostly, but now that you have this new cooperation and all this, I don't know to what of the efforts that you are handling now are more connected to BER, and then on what you're collaborating. Yeah.
Bob?
Yeah, I'm going to give a go at it. I don't know what aspect of biology you're looking at, but we do quite a bit of work looking at biogeochemistry to better understand the carbon cycle and influences in water and water chemistry and so forth, as an example. And there's quite a bit of work in crossover with that other office looking at like genomics and genomic sciences that underpin some of this. We've actually done some joint workshops in the past. And then on a more aggregate level, that program area is very interested in bioenergy and biofuels, right? And next generation biofuel crops and multi-sector dynamics, but also Zhuzhing in the energy exascale Earth system model. We're constantly, funding people, and there's improvements to understanding the evolution of biofuels and biofuel performance and crop types and land use, land cover change, and water dimensions of, increasing or decreasing dependencies on next generation biofuel crops. So there are some connections that may be of interest to you. Those are a few I could think of.
And Renew.
So just to clarify, in BER, there are two divisions. One is the biological system sciences, and the other one is the earth and environmental system sciences. And we belong to the earth and environmental system sciences. I just wanted to say that we are also part of BER. But the other ways that, Bob mentioned, bioenergy crops, that's one way. The other way, and it was more obvious recently, where soil science is an important aspect of the BSSD portfolio. So is it from the EESSD, or the Earth and Environmental System Sciences Division portfolio. You have links to the ESS community through that. You also have links to modeling. So, there are a few soil scientists as part of the Rubisco project that work on understanding, they take the knowledge from the fine scale at from BSSD and translate it into the larger global Earth system perspective. So the Rubisco is the project that from the modeling portfolio that links with the biology from the analysis part of the portfolio. And Bob talked about MSD. You also have links. I mean, no Earth system model is complete without having I mean, though microbial features are not necessarily modeled to that extent, we do see that in the future in the next 10-year domain, there will be more connections across the portfolios. So E3SM is also going to be looking at potentially that. And I'm, yeah,
Well, I have the
Zhuxing
Zhuxing
hand
for
up, so I'd let her speak to
Yeah.
it.
I thought that Bob said, they said also, I want to say already, I just want to add on that. So in addition to the topic Renew and Bob mentioned, I think we are open to any exciting ideas you may have can help the modeling program enhance our modeling capability. I noticed that, Crystal, you are also into big data. For example, you have some machine learning approach, whatever you see the opportunity for that to be applied to the modeling activities. Please submit your application to our open FOAs or just talk with our scientists, talk with us. Yeah, that's all I want to say. Yeah.
Okay, thank you.
Thank you all very much. And Li Wang.
Hello, thank you all for the nice introduction. It's really, I think it's really crucial for me as a beginning faculty. I'm a junior faculty from Purdue University, so it's really helpful to know the programs and also the funded areas. I have a particular question regarding the strategy to engage with any of the existing funding program areas. So I'm really excited to learn there are so many amazing projects, especially there are one or two that are really close to my own research expertise. And I know they're doing amazing work, and I certainly see a lot of opportunity to collaborate with those teams. So what would be your recommendation for the strategy, for the channels for me to skin in the game? And also I noticed, I think that was probably one of you mentioned there's a sub-award opportunity, and I wonder how that particular may work.
Bob.
Yeah, so I think, there's a multi-prong approach here. One is obviously we gave you information on how to look for open calls. Usually they're targeted around topics, and you could wait a while to find one that actually resonates for you. What we really spent a lot of time on, we gave you a roadmap, basically, to projects and activities and communities of practice and venues where not only you can network, but you can actually work as part of communities. But importantly, those various projects, there's always rotation within the projects of sub-awardees, right? So there may be a lead, like a national laboratory lead or a university cooperative agreement. And by and large, there was a core team initially when these things were first conceived, and the sub-awardees have all changed out. They're all different. They rotate out. And what I would encourage you to do is research, use that roadmap, find out who's doing work that you can plug and play with. Tell them that you saw this in this particular venue, that you see some real applicability, and you'd like to have a conversation with, with either the lead or the appropriate task lead, and see if there isn't something you can put together, and maybe attend some of their open meetings and webinars and so forth. But that's the way to, and search them out at AGU. If you go to AGU, say, hey, you want to get a cup of coffee? I'm really interested. We saw this. But that's really, I think, we're coming into austere budget times. Okay. And I think that may be as, if not more productive a venue than waiting for just the right targeted call funding opportunity announcement. So that's just my 2 cents.
Awesome. I think Renew, I think you put your hand up first.
So Bob hit the nail right on the head.
Yeah.
Connecting with the SFAs as they are now is a good way, and many of the SFAs, they want to be successful too. They get peer reviewed. So in order to show their success, they need to show that they are bringing in the right talent for the project. So pitching the ideas to the leads is good. I also wanted to say, and this is something that Zhuxing mentioned in her presentation, if it just didn't come through. I'm sure it came through, but just to emphasize that, it is to say that volunteer to help with review.
Yeah.
All these SFAs go through reviews. This is one way you will exactly find out their strengths, their weaknesses, unique places, and then these things help into the future too. So I wanted to emphasize that. Thanks. Sushing?
Yeah, so yeah, they said so well. we know each other, of course. So the only thing I want to add is that I think Renu maybe mentioned, so for all the large project SFAs, they are typically on a 3-year review cycle. So basically every 3 years, sometimes we delay for some reason, but so this is a great opportunity to give them now. Then for their renewal time period, they need to submit a new proposal. By that time, you found your expertise really aligned with their priority or need you, then they can include you as a sub-awardee or something like that. So just give you the timeline information. Yeah, that's all.
I see. Thank you all.
Virendra.
Hi, I'm Virendra Ghate. I work at Argonne National Laboratory. Yeah, Scott's colleague mentioned that. So I have a question for Renu and Sujin specifically. So I am funded by ASR SFAs. So use ARM data to do process level understanding of marine clouds. That's my research is on. I just do that, and so I'm at a lab. I mean, I made careers, so I sort of know people a little bit more. So normally what guides us in terms of what process we should study is the papers coming out of the modeling programs, right? So for example, Livermore groups, Shui Zheng, Xiaocheng Shi, Steve Klein, formerly, fantastic papers. They guide us what they think is a problem, or also the PNL folks like the Eagles project with Poladma, Variable, we do that. But recently now what has happened is what I find it a strange latency in between. So basically what happened is in their papers, they say that, hey, these are the things that needs to be explored more. We go, we do the study, we explore that. And then, by the way, I know all of them. So I talked to them at AGU, and then I figured out, well, we changed the parameterization anymore. Now we don't use that no more. We've moved on and we use something else now. We do that, and that's been happening sort of back and forth in some sense. Is there a way for us to directly sort of work with them to get that thing going? Because one is on the modeling development side of things, which is much more, there's a communication, you have to sort of really know each other well, and other analysis side of things also. Sorry for a long question.
No, I think, okay, let me answer answer your question. So yeah, first of all, thank you very much for your interest in connecting your ASR research with the modeling program. We really value that connection. I think I expect this kind of question for EESM, because we have so many, such large effort with so many members, right? So the project they have like a roadmap, like for each cycle, each 3-year cycle proposal, approved or that. But they need to adjust their research activity accordingly if there's some particular challenge coming up, something doesn't work. So for that, if you're interested in working with EESM development, it's very critical to be to have a collaborator with EESM team member. So I have a slide listing all the EESM team leads for different groups. First, you can contact them. You contact them, they can point you to a member within their group, or they can work with you themselves. So that's very important. So you can know what's the most recent information on EESM about is still be needed. What we decided they cannot use that anymore on that. So that help.
Thank you very much. Thanks.
And Renu.
So, yeah, what Zushing said can apply to each one of our other projects, like PCMDI also has a focus on clouds and cloud feedbacks and aerosols. So also, Ruby's project has the WASM SFA has connections. But other than that, so this is one thing that it's not as clear when we talk about our FOAs, is the fact that we kind of occasionally encourage, I mean, in our FOAs, the funding opportunity announcements, even to the universities, we encourage collaboration with labs. In many cases, people take it to mean that it is just with the SFAs that are there, but there have been successful SFAs, successful grants where the lead PI has nothing to do with the the lab PI has nothing to do with the SFA. That is another way you bring talent into the system, right? I mean, so maybe SFAs are science-focused areas and labs they act as the hub, but sometimes certain ideas, like all of us, we get set in our tracks. It's difficult to move things further. This is a good time if you find a university partner, have the university join the university partner and write a compelling proposal. That brings the particular, if the project is successful, it brings that project to the fore, and then the labs automatically start recognizing its value also. And so do the program managers, and so that's another option that I wanted to throw out there. Thanks.
Thank you. Yeah, thank you. So one thing, it also works other way around. Many times it happens that somebody from the modeling analysis folks, they said, oh, I would have known you already had that done. I would have just gotten the stuff from you, what I mean? So it's kind of nice thing to know. All right, thank you very much.
One very quick thing to add to the answers there is actually a specific SFA within the ASR portfolio called Threads, which is actually aiming to do, as you said, Virendra, shorten that linkage time to getting ASR process level science into E3SM. Minghua.
Hello, hi, thank you so much for hosting this webinar. So I'm Minghui Diao from San Jose State University. We're a minority serving institution. So my question is going to be more about breaking the barriers between the modeling aspect of type of research and our student and faculty in a minority serving institution. So I've been a long-term user of the E3SM model output, but for a very long time, I often rely on having collaborators, and they have been very nice to share their data and their update with us. But it has been a lot harder for our faculty and students to really get to know all the techniques of running a model. And I can see this is a particular problem with many climate model simulation, probably not only E3SM. My question is, would there be possible like a workshop or a set of tutorials for early career scientists or students, especially at university and managed research institution, that we don't historically have a lot of faculty with similar background, and this would help us to have a taste of every aspect in a kind of a combined package, maybe similar to what I used to attend the NCAR EESM workshop. I know that is a community model, but I don't know if there's any of interest going on with EESM. Thank you.
What a fantastic question, Renu. I'll give you the first bite at this one.
Yeah, and I'm coming at it not just from the E3SM perspective, I'm also coming at it from the general CMIP modeling perspective. And that's something I did not highlight because we're still working through the details. Next year, we are planning to have a monthly hackathon kind of thing where the different tools are discussed. There will be webinars that discuss different capabilities that exist, or what are the easy ways to analyze. And it's also in collaboration with what my colleague Jay also talked about in Earth System Grid Federation. So there will be a series that we have. We unfortunately don't have a list for a sign-up sheet for it as yet. But if you can email me, I will pass your name on to the leads of that particular group so that you and your students can at least sign up and be aware of the different capabilities and different analysis capabilities. 2 or 3 years ago, we had a hackathon that made people aware of how you could analyze CMIP data on DOE machines, and that was feedback from that was that, hey, what we do over the course of 3 months, you helped us do it over the course of a day or two, just because of activities that are already there. So there will be lessons learned. And if this particular hackathon is not open to everybody, at least the webinar links will be made public. Okay.
Wonderful. Zhijing?
Yeah, Minghui, thank you for the question. So yeah, as you mentioned, the EESM is not a community model by design, but we do have a lot of resources, including tutorials you mentioned on the EESM website. I put the link in the chat box.
John.
Oh, okay. So also by kind of to be involved with EESM activity like webinars or on the university project, or like I think your RDPP PIS on that. So involved with EESM, you can have a lot of access to even more information, not on the tutorial for EESM development. And going forward, we'll keep thinking better ways to even share more information. We do have a lot of public data and code, etc., all public. And I'm very proud to say that EESM is the first major climate model pursuing open development kind of practice. Yeah.
And Dan, I do see you there. I'm going to let Bob go and answer this, and I'll hand it over to you for the final question. So, Bob.
Yeah, so similar to Zhijing, you know, the MSD community, again, check out the MSD community practice and MSD Live, which is a portal that's designed to actually enable people to work together with software hosting and webinars and community data platforms. But the GCAM model in particular, which has been open source for quite a while, this is a leading, you know, for us, it's evolved. It's a multi-sector dynamics model, but it grew out of being an integrated assessment model, right? If you're more familiar with that terminology. But they run an annual workshop, and then also as part of the workshop, which is a harder ticket to get, it's a little bit more focused on you know, big modelers than training students. They offer a complimentary set of days for training on the GCAM model. You can access and get the model. The entire model is transferred to you. It's available through GitHub too, but they actually do training, and I can't imagine there's any limitations. There's like 21 different countries actually that get trained on it. There's industry, the energy industry, the environmental industry gets trained on it. There's no cost associated with this training, so that would be a great place to start. But there's video tutorials at that link I put in as well that actually could start the ball rolling. So think of that.
Perfect. And I think Dan and Co, do you have a question? If you do, I'll let the last one go to you.
Yeah, I do. Yeah, I'm with an environmental and energy consulting firm in Maryland, and I've signed into this thing and I've heard, you know, just great volumes about the modeling capabilities and all the interactions between your researchers and so forth. But what I was looking for, though, was, you know, what have you learned from each of these modeling activities, and what are the conclusions? What are the outcomes? What was predicted in terms of, you know, prior weather events or whatever, or what could you say about the future for the atmosphere and Earth trends, and, you know, what extremes that we're experiencing and that sort of thing? I was looking for outcomes. I'm wondering if you can have a meeting where you can focus not so much on the social interaction between the people, but what has come from all this.
And I'll answer that first of all. One thing I need to say, Dan, this meeting was actually specifically designed to encourage new researchers and in the area but I would very much encourage you, and I'll hand it over to the program in a second, to attend some of the town halls at the American Geophysical Union or American Meteorological Society and look at some of the highlights that are actually provided on the various program pages. But Renu, you want to answer that question?
So, yeah, other than through publications and, you know, news articles that come through about the research that has been done as part of our portfolio, you particularly mentioned extremes and extreme events. Hypofacets is a project that has regular webinars that enable the community to understand what is out there in terms of research, and you know, there have been many useful talks that highlight the applications or the results of our science, and looks like that would be very useful for you. So do check out the Hypofacets link from our talk, and that should provide some input. But it's a very good idea for us to potentially do a webinar to highlight the products that we've developed. So thank you for that.
And Bob?
Yeah, I think some of the venues you mentioned, but they're not always accessible to people, but there are remote components to some of them. But the links that we gave you, Dan, I just want to I want to share for a minute if I can, if it's going to let me. I don't know what's going on here. Is it not? Oh, okay. Let's try this one. Share. Okay. So this is embedded in one of the links, and all of our programs have this kind of thing. Okay. But as you can see, these publications, they're talking about the future, right? Hydropower expansion or alternative scenarios, future bioenergy expansion, how stable is the stabilization value of groundwater, uncertainties in crop yields, representing, socioeconomic uncertainty, but implications of imposing fertilizer limitations on energy, agriculture, and land systems. These are spot on, I think, in responding to the kinds of impacts questions that exercises our models for predictive insights, right? So I would really encourage you to get into some of the publications. When you go to those project pages, go to their publications links and start looking at some of it, because there's some very cool things there that I think speak loudly to what you're talking about. Just my thought.
Yeah, what I was hoping to do was to hear what the major conclusions for maybe each one of those areas. In other words, what have you spent $150 million a year? What have you learned? I mean,
and Zhu Jing, I'll give you the final word.
Sure. So Dan, from my perspective, since similar to Bob Renew, I will say, just for your question, I think we have improved model accuracy and also advanced capability with reduced uncertainties for the climate signals, extreme events, or simulations. Use EESM example, we use the dual emission as a target, right, to advance the modeling capabilities. For example, the regional refined modeling capability with EESM developed, you can focus on specific region, like for example, US coast, to zoom in that, to look at how that region will be impacted by kind of large-scale climate change and impacts. And the Earth coupling human feedback, you can look at different decarbonization strategies, how that will have impact on the future climate. And those are very important scientific questions that EESM can enable us to answer to address actionable science for DOE. Yeah, I think that's all from me.
Thank you very much. And thank you to everyone for all your fantastic questions. We will be reaching back out to the email list we sent the invite to, and to all registered attendees, letting you know when more information is available for this and other town halls, the other open houses we ran. So again, I want to say thank you to you, thank you to the program managers, and we'll be in touch soon. So thank you, everyone.
Yeah, thank you, Scott. Thank you
Thanks,
all
Scott,
for
for setting this.
attending.
And thanks, Scott, for organizing.
And Andrew as well. Yes.
Yes, Andrew. Yeah.
Yeah.